A silent mathematical language is carved into the world's oldest stone structures. This video will show you exactly how ancient builders, without any of our modern tools, embedded a profound mathematical intelligence into monuments like the Great Pyramid and Stonehenge. You will discover a hidden legacy of genius that forces us to rewrite our entire understanding of human history. How did cultures separated by oceans and millennia use the same complex geometry? What secret knowledge allowed them to align massive temples with the stars? By the end, you will never look at these ancient wonders the same way again. What does this lost sophistication reveal about our own potential? This mathematical intelligence was a language of stone and sky. It was not written in symbols we would recognize today, but expressed through the very placement of a cornerstone and the precise angle of a rising sun. Forget chalkboards and calculators. This was a living knowledge, a deep, intuitive understanding of geometry, proportion, and the relationships of space. It was the practical skill that allowed a master builder to visualize a perfect square without a modern measuring tape, or to align a temple's doorway so the dawn light would flood its inner chamber on the summer solstice. This wisdom was not bound in leather-covered books. It was carried in the minds of elders and passed from one generation of artisans to the next through song, story, and the patient work of apprenticeship. It was a hidden curriculum where the lessons were in the feel of a stone and the sweep of a constellation's path. The proof of this education was not a passing grade, but a structure that has defied time itself. To see this foundational genius in its purest form, we must journey to where it all began, long before the pyramids pierced the Egyptian horizon. Stand before the Great Pyramid, and you are not just looking at a pile of stones. You are facing a mountain of mathematical intent. Its base stretches across 13 acres, a near-perfect square whose sides align to the 4 cardinal directions with an accuracy finer than 1/15th of a single degree. To achieve this with simple ropes and sighting poles seems almost impossible. Yet the precision only deepens when you look at its proportions. Take the pyramid's perimeter and divide it by twice its original height. The result is a number hauntingly close to pi, the fundamental constant defining a circle's circumference. It is as if the pyramid's designers encoded a circle within a square, a profound geometric joke carved in limestone. Inside the structure, the king's chamber presents another puzzle. The ratios between its length, width, and height form a perfect 2 by 1 by 1 rectangle, a shape whose diagonal forms a 3-4-5 Pythagorean triangle. This specific ratio creates a space of incredible structural integrity, and it was used over 1,000 years before the man, Pythagoras, was even born. These are not happy accidents. They are the clear, deliberate fingerprints of a master plan. So how did they do it? The answer lies not in the stones themselves, but in the tools and the minds that placed them. The same mathematical intelligence appears far from the Egyptian desert, on the windswept Salisbury Plain. Here, over 4,000 years ago, a society we consider Neolithic erected Stonehenge, a structure that functions as a colossal astronomical calculator. We often see its famous alignment, the heel stone capturing the rising sun on the summer solstice. But this is just the opening statement of a far more complex argument written in stone. The monument's geometry reveals a mind that understood cyclical time on a grand scale. Look at the 4 station stones, positioned to form a nearly perfect rectangle within the circle. The proportions of this rectangle are not random. Scholars suggest its dimensions could have been used to predict lunar eclipses, events that would have seemed like the moon itself being consumed by shadow. Even more profound is the outer ring of 56 pits known as the Aubrey holes. This number, 56, is the key to a remarkable cycle. It represents a way to reconcile the shorter lunar year with the longer solar year, creating a 56-year calendar that could track the complex dance of the sun and moon with stunning accuracy. This was not just a temple to mark the seasons. It was a predictive machine, a Neolithic computer built from earth and stone, encoding a deep understanding of celestial rhythms that modern science would take millennia to formally document. The stones did not align themselves. The precision we see etched into the pyramids and stone circles was born from the hands of master builders wielding tools of elegant simplicity. To understand their genius, we must forget our digital levels and GPS. Their world was one of rope, water, and shadow. In Egypt, the Merkhit was their celestial guide. This instrument, little more than a palm fork with a plumb line, was a gateway to the stars. An observer would sight a specific star as it crossed the meridian, the invisible north-south line in the sky. The falling plumb line gave a true vertical reference, allowing them to trace that celestial path directly onto the Earth with astonishing accuracy. It was a stellar clock and a compass all in one. For creating perfect right angles on the ground, they turned to a trusted companion, rope. By taking a cord and knotting it into segments of 3, 4, and 5 units, they could form a triangle. When pulled taut, the angle between the 3 and 4 unit sides is a perfect 90 degrees. This is the practical, hands-on use of the Pythagorean theorem, a principle these builders applied millennia before it was given a formal name. How do you ensure a foundation is perfectly level across a distance longer than a football field? You use the unerring patience of water. A simple trench filled with water, or a length of hose connecting 2 sighting sticks, creates an identical horizontal plane at both ends, no matter the terrain in between. This was not abstract mathematics confined to papyrus. It was a living, breathing intelligence, a knowledge that flowed directly from a fundamental understanding of geometry into the physical world. The true mastery was in knowing which principle to apply and how to manifest it with such humble means. This shared practical knowledge, this toolkit of the ancient world, points toward something even more profound, a set of universal ideas that seem to echo across every continent. This same mathematical intelligence resonated with a specific, almost mystical number, a pattern that echoes from the spirals of a nautilus shell to the very bones of your hand. It is the golden ratio, approximately 1.618, a proportion so fundamental to our sense of beauty that it seems woven into the fabric of the universe itself. In sacred architecture, this ratio, often symbolized by the Greek letter phi, was not just a number, it was a design principle, a secret key to creating structures that felt inherently balanced, harmonious, and alive. Walk through the ruins of the Parthenon in Greece, and you can see its ghost. The dimensions of its facade, the relationship between its height and width, align closely with this golden proportion, creating a visual rhythm that has captivated humanity for millennia. Far across the Mediterranean, the Great Mosque of Kairouan in Tunisia reveals the same underlying geometry in the proportions of its prayer hall and minaret. Now, scholars rightly debate whether every single instance was a deliberate calculation, yet its persistent appearance across continents and centuries points to something deeper than coincidence. It suggests that master builders, through generations of trial and observation, discovered a universal truth. They learned that certain shapes and ratios simply feel right, that they impart a sense of unshakable stability and serene beauty. This was not cold calculation. It was a form of mathematical poetry, an attempt to make stones sing with the same harmony found in a sunflower or a galaxy. This pursuit of perfect proportion was one part of a grander ambition, a desire to build more than just beautiful spaces. These architects were trying to recreate the cosmos itself on a human scale. This celestial ambition transformed entire temples into stone calendars. At the Temple of Konark in Egypt, the main axis was not laid down arbitrarily. It was oriented with such precision that on the winter solstice, the rising sun would fire a beam of light directly down the long avenue, piercing the inner darkness of the sanctuary. For a few fleeting moments, the god Amun-Ra was believed to inhabit his temple, a divine reunion orchestrated by mathematics and masonry. This was architecture as a religious event, a yearly spectacle written in sunlight and shadow. Far across the world, in the high desert of Choco Canyon, another civilization etched the cosmos onto rock. A single slab was positioned with such care that on the summer solstice, a dagger of sunlight slices perfectly through the heart of a carved spiral petroglyph. As the year progresses, the light dagger moves, marking the equinoxes with the same unerring accuracy. These are not isolated wonders. They are part of a global pattern, a field of study we call archaeoastronomy, which reveals how ancient cultures saw a direct, unbreakable link between the heavens and the earth. The orderly progression of the stars mirrored the cycles of life, death, and rebirth. By building structures that tracked these cycles, these master builders did more than tell time. They anchored their communities to the universe itself. They created eternal, unchanging points of reference in a changing world, proving that human beings belonged within the grand cosmic order. This was not just engineering. It was a spiritual act, a way of using mathematics to converse with the gods and secure a place in the eternal rhythm of creation. The precision we see at Stonehenge and Karnak raises a deeper, more perplexing question. Could these master builders have all been using the same ruler? A Scottish engineer named Alexander Thomson spent decades with a theodolite and measuring tape, walking the perimeters of hundreds of ancient stone circles across Britain and France. His data revealed a pattern so consistent it seemed impossible. The diameters of these rings, the spacing of their monoliths, all seemed to be based on a single, standardized unit of measurement. He called it the Megalithic Yard, a length of approximately 2.72 feet. This was not a rough estimate. The unit appeared with a statistical regularity that defied chance, suggesting that the builders from the Scottish Isles to the coast of Brittany were all working from the same architectural blueprint. This single idea shatters the conventional image of isolated, primitive tribes. It implies something astonishing: a web of communication, a shared school of knowledge that stretched across prehistoric Europe. Who were the guardians of this standard? Were they traveling astronomer priests, master masons who carried a sacred measure from one community to the next, ensuring that every stone circle, from the smallest to the grandest, resonated with the same mathematical harmony? The existence of the Megalithic Yard suggests a concerted intellectual project, a continent-wide collaboration to encode celestial knowledge into the landscape. This discovery forces us to look beyond Europe, to wonder if this same thread of shared measurement connects distant continents, revealing a forgotten language of form and number that the entire ancient world might have understood. High in the Andes, a different kind of mathematical genius speaks through stone. At Machu Picchu, the Incas faced a relentless adversary, the shivering violence of earthquakes. Their solution was not to build rigid, monolithic walls that would crack under pressure, but to create something alive, something that could dance with the Earth's tremors. They mastered a technique called ashlar masonry, working with massive, irregular blocks of granite. Each stone is a unique puzzle piece, its neighbor's custom shaped to receive it. The result is a wall where the seams are so impossibly tight that you cannot force a razor blade between them. This is not merely a display of patience. It is three-dimensional geometry of the highest order. The builders had to visualize how each complex, multi-angled face would transfer force, how weight and shock would travel through a network of interlocking forms. They were thinking in topology, the mathematics of shapes and spaces, understanding that a perfectly fitted irregular block creates a friction lock that is far stronger than any mortar. This was geometry applied as seismic engineering. The entire structure becomes a single, flexible entity. When an earthquake strikes, the stones in an Inca wall literally shudder and sway, settling back into place once the shaking stops, while a rigid, mortared wall would crumble into dust. This is the mathematical intelligence in its most pragmatic form, a deep, tactile understanding of material and force, born from the absolute necessity of survival in one of the most geologically active regions on Earth. It stands in stark contrast to the celestial alignments of other cultures, a reminder that this ancient genius was as much about navigating the world below as it was about mapping the heavens above. The name Pythagoras echoes through our math classes, but the truth is his famous theorem was ancient history long before he was born. A Babylonian clay tablet known as Plimpton 322, created nearly 2,000 years before Pythagoras, holds the key. This tablet is not a crude sketch. It is a sophisticated table of numbers, a list of what we call Pythagorean triples. These are sets of three whole numbers that perfectly describe the sides of a right-angled triangle, like 3, 4, 5. Someone over 3,800 years ago was systematically calculating and recording these relationships. They understood the principle completely. This mathematical reality was not confined to a single culture. Look at the flawless right angles of the Great Pyramid's base, or the grid-like precision of ancient Harappan cities in the Indus Valley. Their builders were not guessing. They were applying the same rule, using ropes knotted in the 3-4-5 pattern to lay out perfect corners for their pyramids and streets. This was not a secret formula waiting to be patented by a Greek philosopher. It was a universal truth, a fundamental property of the space we inhabit, discovered and put to use by brilliant minds wherever they built. The theorem was not invented. It was observed like the law of gravity by anyone who looked closely enough at the world. This recurring discovery of the same geometric principles points us toward the ultimate mystery. Who were these individuals? What kind of mind looks at a stretched rope and sees the hidden relationships of the universe? These master builders were more than just brilliant technicians. They were the intellectual and spiritual elite of their time, individuals who held the titles of priest, astronomer, and architect in one person. In ancient Egypt, the legendary Imhotep, the man behind the step pyramid, was not merely the overseer of all the king's works. He was also a high priest of the sun god Ra, a healer, and a sage who would later be worshipped as a god himself. For him, and for countless others like him, there was no distinction between the spiritual and the scientific. Their mathematical intelligence was the very language they used to converse with the divine. To calculate the perfect angle for a pyramid was to ensure the pharaoh's soul could ascend to the stars. To align a temple with the solstice sun was to participate in the cosmic cycle of rebirth. This was not a job, it was a sacred vocation. The knowledge they possessed was not considered a personal achievement, but a sacred trust, a legacy to be guarded and passed down with the utmost secrecy. These were the minds that could hold the vast, abstract movements of the heavens in their thoughts, then translate that cosmic order into the precise placement of a single stone on the earth. Their work was an act of devotion, a prayer built in limestone and granite. This profound worldview, where every measurement was imbued with meaning, gave rise to a language far richer than numbers alone, a symbolic code written into the very fabric of their creations. This symbolic language transformed every measurement into a meditation. A circle was far more than a convenient shape for a stone ring. It was a representation of eternity, having no beginning and no end, a perfect mirror of the heavens and the cycle of time. The square, with its 4 equal sides, was a symbol of the earth itself, of stability and the 4 cardinal directions. When a builder laid out a structure, they were not just planning walls. They were mapping a spiritual journey. In many sacred designs, you see a deliberate progression from a circular foundation to a square superstructure. This was a profound metaphysical statement, a geometric representation of the descent of spirit into solid matter, of the divine becoming manifest in the physical world. Numbers, too, were never just quantities. They were archetypes, each vibrating with its own unique meaning. The number 7 was sacred across cultures, tied to the 7 wandering celestial bodies visible to the naked eye, the sun, the moon, and the 5 classical planets. 12 was the number of the zodiac signs, the complete cycle of the sun's path through the year. This is why a temple was never merely a place of worship. It was a cosmological diagram carved in stone. Every pillar, every chamber, and every ratio was a deliberate choice, a piece of a grand puzzle designed to reflect the order of the cosmos. The mathematics were not cold and sterile. They were warm with meaning, a sacred code that allowed the architect to be a philosopher and the building itself to become a profound theological statement. This deep symbolic layer elevates the simple act of counting stones or measuring a foundation into something far greater, a conversation with the universe itself. A single, barren ridge in Peru holds the ruins of the oldest solar observatory in the Americas. Long before the Inca Empire, over 2,000 years ago, a people we call the Casma Sechin culture engineered a calendar of stone that still marks the passage of time with unerring accuracy. They built 13 towers marching like a stony spine across the hilltop of Chankillo. From a distance, they appear as a row of jagged teeth, an artificial horizon carved by human hands. But stand in one of 2 specific observation points, one to the west and one to the east of the ridge, and the true genius of this place awakens. On the morning of the December solstice, the sun rises directly to the right of the first tower. The next day, it rises just a little further left, and so it continues, its rising point marching along the line of towers until, on the June solstice, it crests the horizon at the far left of the 13th tower. Then it begins its journey back. The entire solar year, all 365 days, is perfectly mapped across this stone ruler in the sand. The mathematical intelligence here is breathtaking. It is not just in the towers themselves, but in the empty space between them. The builders did not space the towers evenly. The gaps correspond precisely to the changing declination of the sun, the subtle north-south wobble in its path through the sky over the course of a year. They translated a celestial motion into a fixed terrestrial measurement. This was more than a temple for priests. It was a public clock, a civic calendar built into the very landscape. Anyone who knew where to stand could look at the sunrise and know the exact date, could plan for planting or a festival with certainty. This complex predates Machu Picchu by more than 1,000 years, forcing us to rewrite the timeline of astronomical science in the Americas. It stands as a silent, powerful testament to a universal human drive to capture time in stone, proving that this profound mathematical intelligence was not a fluke of one culture, but a spark that could ignite anywhere on Earth. The number pi whispers its presence from the very stones of the Great Pyramid. Its base perimeter, divided by twice its original height, yields a value extraordinarily close to this irrational constant. This is not a coincidence. It is the signature of a profound geometric problem known as the squaring of the circle. This was not merely a mathematical puzzle. It was a philosophical quest, a symbolic act of unifying the earthly realm, represented by the stable, four-cornered square with the divine and eternal, embodied by the perfect, infinite circle. To create a square with the same area as a given circle was to harmonize the material world with the spiritual cosmos. The Egyptians may not have known pi as the abstract number we write today. Their practical methods, preserved in documents like the Rhind mathematical papyrus, used a working approximation. They understood the relationship well enough to embed it into the most important structures ever built. The Great Pyramid stands as a physical representation of this mystical challenge. Its square base and its soaring, pyramidion-topped height, which once pointed directly to the circumpolar stars, create a geometric poem where the circle of the heavens is squared upon the earth. This fusion of math and metaphysics reveals a world where numbers held a power far beyond the merely practical. They were the very tools for bridging the human and the divine, for making the invisible patterns of the cosmos visible and permanent in stone. Deep beneath the island of Malta lies a sanctuary of sound, the Hypogeum of Hal Saflieni. Carved from solid limestone over 5,000 years ago, this labyrinthine temple holds an acoustic secret. In a specific chamber known as the Oracle Room, a deep male voice resonates at a frequency of 110 Hz. This is not a gentle echo. It is a powerful vibration that fills the entire room, a resonance so pure it seems to physically press upon the air. Modern studies suggest this specific frequency can directly influence human brain activity, shifting patterns from active beta waves to the more meditative, receptive states of alpha and theta. The builders did not carve this chamber by chance. They engineered it, using the precise dimensions of the stone to create a tuning fork for the human mind. This sonic architecture is echoed millennia later in the soaring vaults of Gothic cathedrals. The vast naves are not just tall for dramatic effect. Their proportions, often based on simple ratios like 2 to 1 or 3 to 2, were carefully calculated to amplify and sustain sound. A single chant or note would linger in the air for seconds, blending with others to create a rich, enveloping tapestry of harmony. This was the mathematics of sound made manifest, a geometry of resonance. The ancient master builders clearly understood the physics of sound waves, how they reflect, interfere, and amplify within a space. They were not merely constructing buildings. They were crafting instruments, immense violins and cellos made of stone, designed to elevate the human voice into something transcendent. This was a mathematical intelligence that spoke directly to the spirit through the body, using harmonic resonance to dissolve the boundary between the physical and the spiritual. It reveals a holistic vision where number, form, and frequency were woven together into a single, immersive experience, proving that their genius was meant to be not only seen but deeply, profoundly felt. Far from the solitary stone circles and the towering pyramids, this mathematical intelligence found a different expression, one designed for the daily life of thousands. In the fertile Indus Valley, around 2,500 years before the Common Era, the city of Mohenjo-Daro rose from the plains. This was not a haphazard collection of huts. It was a masterpiece of urban geometry, a city laid out on a rigid grid plan with streets running in perfect north-south and east-west alignment. This was not a matter of chance. It was the result of a deliberate, large-scale design, a conscious application of mathematical order to human society. The precision extended to the very materials of the city. Every building was constructed from standardized kiln-fired bricks, and these were not just any bricks. their dimensions, the length, width, and height, all maintained a consistent ratio, typically 4:2:1. This standardization meant that a brick made for one house would fit perfectly into a wall in another, or into the city's massive defensive citadel. Imagine the coordination required, the foresight to establish a universal building module for an entire metropolis. This points to a powerful, centralized authority, one that possessed a sophisticated understanding of geometry, logistics, and mass production. The mathematical intelligence here was not aimed at the stars but at the Earth. It was a geometry of social organization and public health. The grid system allowed for an efficient drainage network, with covered channels running alongside the main streets, directing waste away from homes and ensuring a level of sanitation that would not be seen again in many cities for millennia. This was mathematics applied to create a functional, orderly, and healthy living space for tens of thousands of people. At Mohenjo-Daro, we see a different facet of this ancient genius, one that moved beyond the sacred and celestial to build a truly practical and remarkably modern urban civilization. The story of this ancient intelligence does not end with the pyramids or stone circles. It echoes into the modern era with a mystery carved from coral rock in 20th century Florida. A frail Latvian immigrant named Edward Līdzkalnis, standing just 5 feet tall and weighing barely 100 pounds, single-handedly built what he called his coral castle. Over the course of 28 years, working almost entirely alone and often under the cover of night, he quarried, shaped, and positioned over 1,000 tons of massive coral blocks. The result is a sprawling complex of immense stone gates, towering obelisks, and perfectly balanced rocking chairs, all carved from solid rock. How did one man, with no modern machinery, move a 9-ton gate so perfectly balanced that a child could push it open, yet so precisely fitted that it took a team of engineers with a 20-ton crane to budge it after it seized decades later? Līdzkalnis himself was cryptic, claiming only that he had rediscovered the building secrets of the ancient Egyptians. He said he understood the laws of weight and leverage, speaking of a lost knowledge concerning the magnetism of the Earth and how to counteract gravity itself. He left behind no blueprints, only grainy photographs and his own enigmatic writings. To this day, no one has convincingly replicated his methods. This modern enigma forces a profound question. If a single man in the 1900s could seemingly defy conventional physics using principles he claimed were ancient, what does that say about the true capabilities of the master builders who came before him? The coral castle stands as a stubborn, tangible puzzle, a modern monument that suggests the ancients might have possessed a sophisticated grasp of natural forces, a physics of stone and earth that our own science has yet to fully comprehend. But this river of knowledge did not flow uninterrupted. The very empires that nurtured this mathematical intelligence eventually crumbled, and with their fall came a great forgetting. The legendary Library of Alexandria, a repository of ancient wisdom from across the known world, was consumed by fire, its scrolls turning to ash and taking untold secrets with them. As new religions rose to prominence, the old pagan worldviews, with their star-aligned temples and earth-bound geometry, were often suppressed. The deep cosmological reasons for a temple's specific proportions, the philosophical meaning behind the squaring of the circle, these were no longer central to faith. The practical skills of the stonemason survived, of course. Cathedrals still needed to stand, but the sacred context, the profound understanding that a building was a model of the cosmos, began to fade from common memory. This esoteric knowledge did not vanish entirely. It went underground, preserved in fragments by secret societies and the guarded rituals of medieval guilds. The master mason's compass and square became cryptic symbols, their original cosmic significance known only to a select few. This loss represents one of history's great intellectual tragedies. It was a severing of our connection to a holistic way of seeing, a world where number, spirit, and stone were woven into a single, magnificent tapestry. Recognizing this profound break makes our modern quest to decipher these ancient codes not just an academic exercise, but an urgent recovery of a lost part of our own human genius. Rolling toward the Bay of Bengal, the Sun Temple of Konark stands as a colossal stone chariot frozen in mid-journey. Its 12 pairs of wheels, each exquisitely carved, rise high above the ground, but their purpose transcends decoration. Look closely at any one of these massive stone discs. The 8 thin spokes radiating from the hub are not just artistic flourishes, they are the teeth of a giant clock. As the sun arcs across the sky, the sharp-edged spokes cast distinct, moving shadows across the meticulously carved markers on the wheel's rim. These markers allow an observer to read the time of day with a precision that rivals any mechanical clock, capable of measuring intervals as small as a single minute. This was timekeeping on a monumental scale where the entire temple complex became a divine timepiece. The alignment of the structure reveals another layer of intent. The main entrance faces the eastern horizon with such precision that the dawn's first light during specific periods of the year would flood directly into the sanctum, as if the sun god Surya himself was arriving in his chariot to begin the day. Here, art and science are inseparable. Every sculpted figure, every dancing deity, and every mythical beast adorning the walls exists within a framework of profound mathematical order. The temple is a perfect symphony of form and function, a place where devotion was expressed not only through prayer but through the silent, unerring measurement of time itself. It stands as a breathtaking testament to the idea that to understand the cosmos is to participate in the divine. This same mathematical intelligence often unfolds like a living spiral. A nautilus shell expands its chambers in a perfect logarithmic curve. A sunflower head packs its seeds in 2 opposing sets of spirals, and even the branching of a tree follows a specific, efficient pattern. Underlying many of these forms is a simple sequence of numbers 0, 1, 1, 2, 3, 5, 8, 13, and so on, where each number is the sum of the 2 before it. This is the Fibonacci sequence, a pattern of growth so fundamental it seems to be a universal rule for building complexity from simplicity. The sequence is intimately connected to the golden ratio, as the ratio between consecutive Fibonacci numbers gets closer and closer to that magical proportion of 1.618. Now, did ancient architects consciously calculate the Fibonacci sequence when they laid their foundations? The evidence is less direct than the precise right angles of a pyramid. But the pattern is undeniably there, resonating in the very spirit of their designs. Consider a structure like the Parthenon. When you analyze its facade, the relationship between its major elements, the width of the steps to the height of the columns, often falls into ratios found within the Fibonacci sequence. It creates a visual rhythm that feels less like a rigid calculation and more like a natural progression, as if the building itself were growing organically from the ground. This was not about slavishly copying a mathematical formula. It was about observing the deep grammar of nature, the recursive, self-similar patterns that life uses to build itself. By weaving these patterns into their temples, the master builders were not just constructing a building, they were trying to capture the essence of life itself, to create spaces that felt inherently alive, balanced, and harmonious because they mirrored the very processes of the living world. They sought to build not against nature, but as an extension of it, using mathematical principles of growth to make stone feel as dynamic and purposeful as an unfolding leaf. This pursuit reveals a final, breathtaking layer of their ambition, a desire to not only map the cosmos, but to replicate its most fundamental creative act. The Gothic cathedral is a prayer built in stone and light. Step inside Chartres, and you're not merely standing in a church. You are inside a three-dimensional geometric proof, a space where every line and curve whispers a sacred secret. The master masons who conceived these structures worked from a hidden blueprint, one composed of the square, the circle, and the triangle. These were not just shapes to them. They were the fundamental building blocks of God's creation, the pure forms through which divine order could be made visible on earth. The entire floor plan of the cathedral might begin with a single square. That square would be subdivided, its diagonals crossed to find the center, its sides extended using a compass to generate new proportions. From this simple starting point, the entire complex organism of the cathedral would unfold, its rhythms dictated by an unshakable geometric logic. Look up at the soaring ribs of the vaulted ceiling. They are not random arches. They are the manifest lines of invisible triangles and circles, intersecting to distribute the immense weight of the stone outwards and downwards, creating a skeletal structure of breathtaking strength. This engineering marvel is what allowed the walls to become seemingly insubstantial curtains of glass. The vast stained glass windows, with their deep blues and radiant reds, are not interruptions in the stone. They are the geometric plan's ultimate purpose, the transformation of heavy matter into immaterial, divine luminosity. When the sun streams through a rose window, casting a kaleidoscope of colored light across the nave, you are witnessing the final step in a mathematical ritual. The geometry captured the light, and the light became the presence of God. For the medieval mind, this was not a metaphor, it was a physical reality. To calculate a perfect ratio was to think God's thoughts after him. To raise a vault according to these principles was to use human reason, the gift of a logical creator, to build a ladder back to that creator. The cathedral was a bridge between earth and heaven, and the mortar that held it together was a profound faith in the mathematics of the cosmos. Beneath the waves off Japan's coast, a stone enigma sleeps. The Yonaguni monument rises from the seafloor, a colossal arrangement of terraces, platforms, and sharp cliffs that look unnaturally geometric. Its features are startlingly precise. You can trace long, straight edges that run for meters without a single curve. You find perfect right angles where one stone face meets another, and what appear to be staircases climbing the structure in measured, even steps. The sheer scale is humbling, a complex of formations that dwarfs any human who swims beside it. The central question is as deep and murky as the surrounding waters. Is this all a spectacular trick of nature, a masterpiece of underwater erosion that just happens to mimic human architecture? Or are we looking at the submerged ruins of a megalithic structure, built on dry land over 10,000 years ago before rising sea levels claimed it for the ocean? If this is indeed a human creation, the implications are seismic. It would mean a previously unknown civilization, possessing advanced stone working skills and a sophisticated understanding of geometric planning, was thriving at a time when conventional archaeology tells us humans were simple hunter-gatherers. This single site, with its hauntingly familiar right angles and platforms, threatens to push the entire timeline of human architectural and mathematical genius back into the fog of prehistory. It suggests that the spark of this intelligence ignited not just in the familiar cradles of Egypt and Mesopotamia, but perhaps independently on the very edge of the Pacific, in a culture whose name and story are now utterly lost to the sea. This underwater mystery does not simply add another monument to our list. It challenges the foundational narrative of human progress itself, forcing us to wonder what other chapters of our past are still hidden, waiting on the ocean floor. The silent language of the ancient geometers did not fade into history. It simply found new interpreters. In the 20th century, the pioneering architect Le Corbusier became obsessed with a single question. Could he find a universal system of proportion, one that would bring the same harmony to modern buildings that the ancients achieved in their temples? His answer was the modular, a scale of measurements based directly on the human form and the golden ratio. He saw this not as an invention, but as a rediscovery of a timeless truth, a way to make a room or a building feel inherently right to the person standing within it. This was the old intelligence reborn for the machine age. At the same time, the visionary Buckminster Fuller looked to nature's own geometry for solutions. His geodesic domes, those beautiful spheres made of interconnected triangles, are a direct echo of the strength found in a carbon molecule or a viral capsid. They achieve maximum strength with minimal material, a principle of efficiency that the master builders of old would have instantly recognized and admired. This ancient understanding of form and force now extends far beyond the scale of human habitation. In the realm of particle physics, scientists probing the fundamental structure of reality are guided by geometric models. Complex shapes like the seed of life, a pattern of interlocking circles revered in sacred art for millennia, are now studied as potential blueprints for the very fabric of space-time. The legacy of these ancient minds is not locked in stone. It lives on in the curves of our most innovative architecture and in the equations that seek to explain the birth of the cosmos, proving their insights were not just for their time, but a perpetual key to understanding the universe itself. This search for meaning forces us to confront a critical question. Are we witnessing the ghosts of a true design, or are we simply seeing what we want to see in the ancient stones? The line between profound insight and pure pareidolia can be dangerously thin. Take the famous Orion correlation theory, which suggests the three main pyramids at Giza are a perfect terrestrial map of the three stars in Orion's belt. The idea is captivating, a celestial blueprint written in limestone. Yet, when astronomers and archaeologists plot the stars' positions from that era against the pyramid layout, the match is not quite perfect. The relative sizes and spacing of the pyramids differ from the relative brightness and positions of the stars. This does not necessarily invalidate the connection, but it introduces a crucial note of caution. Our modern minds, steeped in star charts and eager for cosmic connections, can sometimes force a pattern where the ancient builders may have had a different, more nuanced intention. This is where serious researchers draw a vital distinction. They do not rely on visual similarity alone. They employ statistical analysis, asking what the probability is that such an alignment could occur by pure chance. They immerse themselves in the archaeological context, searching for clues in ancient texts, artifacts, or other sites built by the same culture that might confirm a deliberate celestial theme. This rigorous, evidence-based approach is our only reliable compass. It allows us to separate the genuine fingerprints of mathematical intelligence from the seductive whispers of coincidence. Our fascination with these mysteries is powerful, but it must be tempered with intellectual honesty. By embracing a critical eye, we do not diminish the wonder of the ancient world. We honor it. We ensure that the story we tell is not one of our own modern fantasies, but one that is truly written in the stones themselves. These recurring patterns of pi and the golden ratio force a startling possibility. Perhaps these unconnected cultures were not inventing this knowledge from scratch, but were instead inheriting fragments of a much older, shared tradition. The same geometric principles appear in the pyramids of Egypt, the temples of Angkor Wat, and the stepped pyramids of the Maya, cultures separated by vast oceans and thousands of years. How could such specific mathematical ideas emerge independently across the globe? One compelling answer points to a lost root civilization, a fabled society like Atlantis or a forgotten precursor culture whose master builders sailed the world, planting the seeds of their wisdom before a cataclysm erased them from history. This would explain the startling similarities as a legacy, a common architectural language passed down from a single, sophisticated source. Yet another theory is even more profound. It suggests there was no teacher, no sunken continent. Instead, this knowledge is hardwired into the human mind itself, a universal consciousness that intuitively grasps the fundamental ratios of nature. When a builder contemplated perfect harmony, their mind naturally drifted toward the golden ratio because that proportion is the very grammar of beauty in the natural world, from the spiral of a galaxy to the curve of a seashell. They were not copying a blueprint, but rediscovering a universal truth each time they laid a stone. This idea fundamentally challenges our linear view of history, where humanity slowly climbs from primitive to advanced. It paints a picture of a much more interconnected and intellectually vibrant ancient world, one where the same deep truths about the cosmos could dawn simultaneously on different continents. Whether through a lost teacher or an innate awareness, these monuments stand as a collective human testament to a single, haunting idea, that the universe is built on a mathematical foundation, and we, in our deepest intuition, have always known it. Our journey across continents and millennia reveals a stunning truth. The builders of these ancient wonders were not simple people groping in the dark. They were master geometers, astronomers, and engineers whose intellectual legacy is carved into the very bedrock of our world. From the solstice-aligned towers of Chankillo to the celestial geometry of the Great Pyramid, they were doing far more than stacking stones. They were building cosmologies, creating physical models of the universe designed to harmonize human life with the grand cycles of the cosmos. They encoded the principles of Pi and the golden ratio not as abstract curiosities, but as sacred truths, embedding the fundamental mathematics of nature into their most holy spaces. This legacy shatters the outdated notion of a linear progression from primitive to advanced. It forces us to expand our very definition of intelligence beyond written text and digital technology. We must now look upon these monuments with a new and profound respect, seeing them not as mysterious ruins, but as the brilliant, intentional creations they truly are. The stones have spoken a clear and consistent message. They tell of human genius, of a deep, intuitive connection to the mathematical fabric of reality. This is not the end of a story, but an open invitation. An invitation for you to look deeper at the world's ancient wonders, to question the standard narratives of history, and to share your own thoughts and discoveries in the conversation below. What secrets do you believe are still waiting to be uncovered?